A 6, minus 1, B 12, minus 3, C 8, 5, and D 2, 7 are 4 points. Plot the 4 points on the diagram below. Okay, let's look at the point A. Its x value is 6, its y value is minus 1. B has coordinates 12, minus 3. Go to 12, minus 3 is here. Okay, this is minus 3 on the y-axis. C has coordinates 8, 5. And D has coordinates 2, 7. So you see we have a quadrilateral or a four-sided figure formed. Describe two different ways of showing, using coordinate geometry techniques, that the points form a parallelogram ABCD. Well, we definitely have a four-sided figure. I've only drawn this roughly here. But, you know, is this quadrilateral a parallelogram? So, what are the conditions for a quadrilateral to be a parallelogram? Well, if opposite sides are parallel to each other, then the quadrilateral is a parallelogram. That's one condition. If opposite sides are parallel, then it's a parallelogram, and we're done. But that's not the only way we can show that a quadrilateral is a parallelogram. But we will start by noting down this particular way. So, I've just stated what I said earlier. ABCD is a quadrilateral if AB is parallel to DC, so AB and DC are opposite sides, and AD is parallel to BC, AD and BC are the other pair of opposite sides, then the quadrilateral ABCD is a parallelogram. Quadrilateral just means a four-sided figure. Quad, that prefix quad should suggest four sides, four something. Four sides in this case, laterals are sides. So how do we use coordinate geometry techniques to prove that AB is parallel to DC and that AD is parallel to BC? How do we prove that two line segments are parallel? Well, we get the slopes of the two line segments. If the slopes are the same, then the lines are parallel. So if the slope of AB equals the slope of DC, then AB is parallel to DC. Similarly for sides AD and BC. So here is the first method for showing using coordinate geometry techniques that ABCD is a parallelogram. We won't actually show it for this particular one, not at this point anyway. Let's consider a second way of showing that the quadrilateral ABCD is a parallelogram. What we do is look at the two diagonals of the quadrilateral. If we find that the two diagonals bisect each other, then the quadrilateral is a parallelogram. If we find that, say, the distance from A to this point here equals the distance of this point to C, and if we find that the distance of D to this point is equal to the distance of this point to B, then ABCD is a parallelogram. So how can we use a coordinate geometry to test to see if AO equals OC and if BO equals OD? Well, what we do is we get the midpoint of the line AC, and then we get the midpoint of the line, the diagonal BD, and if the two midpoints are the same point, then ABCD is a parallelogram. So if the midpoint of the diagonal AC equals the midpoint of the diagonal BD, then ABCD is a parallelogram. By the way, I've put two ticks on the line segment OD. It doesn't mean that OD is twice as long as OC. I put two ticks to distinguish the line segment, the length of the line segment OD from OC. In general, OC and OD are different. In part C, we want to use one of the ways described to show that ABCD is a parallelogram. So what I will do is use the second way. I will look at the midpoints of the diagonals of the parallelogram ABCD. Well, of the quadrilateral ABCD. We don't know that. We're not supposed to know that it's a parallelogram. So AC is one of the diagonals of the quadrilateral ABCD. Let's get the midpoint of AC. Well, to do that, we get the mean of the x values of the points A and C. The x values are 6 and 8. To get the mean of 6 and 8, we add 6 and 8 together, which is 14. Divide that by 2, which is 7. To get the y value of the midpoint, we add the y values of points A and C together. So that's 5 minus 1, which is 4. Then we divide by 2, which is 2. So we get the point 7, 2. Now we get the midpoint of the diagonal BD. So B has coordinates 12 minus 3, D has coordinates 10, 2, 7. So we get the mean of the x values of the 2 points. So 12 and 2 is 14. 14 divided by 2 is 7. So that's what we have here. Then we get the mean of the y values. The y value of D is 7. 7 plus minus 3 is 4. 4 divided by 2 is 2. So you see we get the same point. So the midpoints of the two diagonals are the same for this quadrilateral ABCD. So that tells us that ABCD must be a parallelogram. You see that the diagonals must bisect each other if the midpoint of AC is equal to the midpoint of BD. That's the answer to the question, but what I will do now is use the other method to show that ABCD is a parallelogram. So I'll quickly just run through that. We've answered the question, but in case you decide to do it the other way, we need to show that the slope of AB equals the slope of DC. I won't actually write this out, I'll just use the diagram. To get the slope of the line AB, we would get this distance here and divide it by this distance here. This would be y2 minus y1 over x2 minus x1. This distance, as you can see, is 2 units long, and this distance here is 12 minus 6, which is 6 units long. And you'll see it's the same for the line DC. We get the same triangle formed, same right angle triangle. This is 2 and this is 6 as well, actually. See we have 8 minus 2 is 6 here. So straight away then we can see that AB is parallel to DC. So this is just a quick way of doing it. I'm not going to go into write it out more fully, but we're just looking at the slopes. Similarly, for the other pair of opposite sides, we get the slopes by just drawing in these two triangles. This yellow triangle is congruent to this yellow triangle here, which means that this side is parallel to this side. So if the opposite sides, if both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram.